So now we are going, after discussing about the uses of some of the non-metallic compounds, we are going to discuss about some of the metallic compounds in our daily life. So you have seen that in photography, in electroplating and electrical industry, certain sort of metallic compounds are also used. So we are dealing with now some of the important metallic compounds. So our topic is some important compounds of metal. So in this category, we have our first compound, that is silver nitrate, having a general formula AgNO3. Now, this silver nitrate is basically known as lunar caustic, and it is a white colored crystalline substance which is generally soluble in water. Now, in case of the photographic plates, in laboratory reagent and in used for making certain salt of silver, this silver nitrate is basically used, and it is also used for silvering of mirrors sometime. So, our first compound is silver nitrate. This silver nitrate is having a chemical formula AgNO3, and this compound is also known as lunar caustic. So the important points regarding this will be, it is known as lunar caustic. Now the second property is, this component is actually white colored transparent crystalline substance which is generally soluble in water. So it is colorless white colored crystalline substance. Third characteristic is that it is generally soluble in water. So it will be soluble in water. So these are actually the properties of the silver nitrate that I am describing here. Now coming to the uses, the first use of silver nitrate it is used in making the photographic plates. In photography, it has its extensive use. It can be also used as a laboratory reagent. It is used for silvering of the mirrors. It is used for making other salts of silver that is used for other purposes also. So its uses of silver nitrate are used as a laboratory reagent. Next, in silvering of mirrors. Next use, used for making other silver salts. So these are some of the uses of silver nitrate that we have discussed here. Now why we are studying this? Because a 1 mark question that may be asked in your board exams as well as competition can be arise from these type of the topics. So these are the simpler topics, easy to learn, but you have a bit confusion between different uses. So firstly you have to categorize all the components and learn thereby. Now after silver nitrate, we are moving to our next compound, which is a metallic compound, and this compound is silver bromide. Now this silver bromide, the symbol for silver is Ag and for the bromide it is Br. So the structural formula or the chemical formula for this type of component will be AgBr. Now this silver bromide is actually a pale yellow in color, crystalline solid and generally insoluble in water. It has its one application that it is used in photography. So this component will be used in the photography session. So now, what are the general characteristics? It is pale yellow in color. Next characteristic is, it is a crystalline substance. Which is usually insoluble in water. Usually insoluble. And it is basically used in photographic plates. So its use is in photography. So these are the uses of some of the metallic compounds we have dealt here. Now we are moving to our third compound, that is potash alum. So students, you have basically heard about the potash alum, which is called fitkari in Hindi, which is used to purify the water for our household purposes. As the water contains some dust and dirt particles, so the impurities after dissolving in the potash alum will settle at the bottom of the tank or the bottom of the container. So generally it is used for the purification and the softening of water. So our next component is potash alum. Third component is potash alum. Now, it is a common name to use the term, that is alum, but why it is called potash alum? Because it is the salt of potassium. So it is basically known as potash alum. So it is having a chemical formula, that is K2SO4 dot Al2SO4 whole thrice dot 24H2O. So this is the general formula for potash alum. So 1 mark question is again asked from this type of the question, that what will be the general formula for potash alum. So you can see here K2SO4 dot Al2SO4 whole thrice dot 24H2O is the general formula for potash alum. Now this potash alum is actually a crystalline solid having a transparent nature and generally soluble in water. As you can see here, it contains a large amount of water of crystallization. The water that is attached to it is known as the water of crystallization. So if we are going to heat such type of component, it expands in volume. Why it is expanding in volume? Because it contains a large amount of water of crystallization along with it. So the general properties of the potash alum are, it is a double salt. Double salt means it contains two of the sulphate salts here. So it is a double salt of potassium and aluminium. Second property is that it is a crystalline solid which is soluble in water. But on heating, it will expand its volume because it contains a large amount of water of crystallization along with it. So next property is that on heating, it expands its volume. And finally, it's the most common use of potash alum is, it is used in softening of water. So its use is, it is basically used in softening of water. So these are the general uses of some of the compounds related to metal here. Now we are left with only one compound, that is copper sulphate. But before proceeding to this, you can copy it from here. So we can proceed to our next topic. Now our next compound is copper sulphate. The fourth category of the compound is copper sulphate. Now this copper sulphate CuSO4, that is known as blue vitriol, is having a general formula CuSO4.5H2O. Now this type of compound is generally a crystalline substance having blue color solid structure, and on heating it will lose its water of crystallization attached with it. Now we will discuss its general use, but firstly we will see how the water of crystallization has been lost in case of the copper sulphate solution. So the copper sulphate is basically known as blue vitriol. I am again repeating, this type of component is termed as blue vitriol as its structure, that is copper, will be in blue color. So it is known as, so it is blue in color and it is known as blue vitriol. It is known as blue vitriol. It is having a general formula CuSO4.5H2O. So you can see here the 5H2O is the water of crystallization that is attached to copper sulphate solution. Now what will happen, generally it is blue in color having a crystalline structure which is generally soluble in water. So these are its basic properties, that is it is crystalline solid, usually blue in color. Now what will happen next, when copper sulphate solution is heated, when copper sulphate solution is heated and when it is heated at 373 Kelvin. So what we can see here, that it will lose its 4 water of crystallization and 1 water of crystallization, that is H2O, will remain attached to it. So what we will get in the product side, we will get CuSO4.H2O. Now if we are again heating that component at the temperature of about 413 Kelvin, we are heating it at again 413 Kelvin. If I am heating it at 413 Kelvin, it will lose its water of crystallization and we will get copper sulphate here, that is CuSO4. Now again increasing the temperature, if we are increasing the temperature to 473 Kelvin, temperature is increased to 473 Kelvin, what we will get? We will get copper oxide along with the sulfur dioxide. So what are the products here? The products here will be CuO plus SO2. So this will be the general representation how copper sulphate will going to lose the water of crystallization. Firstly, it is heated at 373 Kelvin and 4 H2O molecules will be liberated from it and 1 water of crystallization will remain along with it. Now in the second step, you can see here at the temperature of about 413 Kelvin, the copper sulphate solution will remain, and if it is again heated at a very high temperature, that is 473 Kelvin, it will dissociate into copper oxide plus sulfur dioxide. So this is the general equation or the general representation of water of crystallization. Now, after discussing about the properties of that blue vitriol, now we are going to discuss about some of the important uses in our day-to-day life. Now, the next topic is uses of blue vitriol. Now, the first and the foremost use of the blue vitriol is that it is used in electroplating, it is used in batteries. A Bordeaux, a mixture of copper sulphate and lime, is used as a fungicide. Next, it is used for the preservation of wood, and sometimes it is also used as a laboratory reagent. So, some of the general applications are in electroplating. In electroplating, blue vitriol is generally used. In batteries, reagent in laboratory, it is used in preservation of wood, and finally a Bordeaux mixture, that is a mixture of copper sulphate and lime, is used as a fungicide. So last use will be its last use is Bordeaux. This Bordeaux is actually a mixture of lime plus copper sulphate. So this Bordeaux is actually a mixture of lime and copper sulphate, and this mixture is generally used as a fungicide. It is used as a fungicide, so it is the another application of the blue vitriol. So students, we have seen here some of the important compounds of the metal, that is silver bromide, silver nitrate, copper sulphate and the potash alum. So likewise, there are many components exist in nature which are formed from metal, and these are some of the important components we have discussed here. So this topic is over for today. We will deal with many more topics in our next lecture. Thank you so much and have a nice day.